Hi, in this video we're going to take a quick look at the for loop. Now I want to first of all discuss the for loop in other languages in case you've actually used them before and run across them in languages like C or C#, Java and so on in JavaScript, because this is kind of the way that for loops might be written. So for, then you declare some kind of loop variable maybe, and you start it at some initial value. So that is code that will run one time before the loop starts executing. Next, you have the condition for the loop to continue executing. So you might have, let's say, I is less than 5. So every time that the loop finishes its code block, it goes back to the beginning and it checks that condition. If that condition is true, it will then execute the for loop again. And then finally, we have a piece of code that gets run at the end of every iteration. So very often, this is how it's kind of written. And then you have your code block in here, and, that is your loop. So that's how for loops work in many other languages, in C-style languages. But of course, that's not at all the same in Python. The Python for loop in this kind of state doesn't exist. There is no such thing. So before we get to that, I want to then define something called an iterable. Now an iterable, and I'll just put in this definition right here, it's in the notebook that you can download, but an iterable is an object capable of returning values one at a time. So an iterable, and please note, I didn't say that an iterable was a collection of values that could be returned one at a time. I just said an iterable is an object capable of returning values one at a time. And we'll see what that means when we start looking into things like iterators and generators later in this course. But it's not quite the same thing as a just list of stuff. Now, lists are iterables, right? So we have lots of objects in Python that are iterable. Tuples are iterable, strings are iterable, and many others. So let me go back to this piece of code right here, because I just want to show you that although we don't have this, this is something that basically just does repetition. The for loop is something that will allow us to iterate over an iterable. So it will basically go and get the next value, as it's running the loop, which is not the same thing as this thing over here. Now we can write this equivalently in Python, and the way to do it is to use the while loop. So the while loop is probably the closest thing that you'll find to the for loop of these other C-style languages, which also have a while loop too. And in fact, in those languages, you can always rewrite a for loop as a while loop, because it really just means that it does certain things. So if I wanted to rewrite this over here, specifically in Python, then I would write it this way: I equals 0. Then the next thing is we have to do a while loop, and we want to continue running as long as I is less than 5. Okay, so here we go. Now we need to do our code block. I'm just going to print I. Okay. Now the next thing is that this is the piece of code that runs after the end of each iteration. Well, that's what we have to do here. We have to increment I. Now we don't have a plus plus operator in Python, but we can write it as I plus equals 1. Now the only difference is that once this for loop has finished executing, the I variable goes out of scope. It goes away, basically. It gets discounted. And so we can do the same thing. We can just say I equals none. Now, you'll see that later on when we take a look at memory and memory references, you'll see that we don't actually need to do this. This will actually get done for us automatically, and in certain cases, actually, this will not even help. So, you run this is it. So we have the same for loop. But of course, that's not what the for statement is in Python. It is something to iterate over an iterable. Now an iterable, a very simple iterable that you can create is by using the range function. So you've probably seen this before. For I in range, let's say 5, and then we'll print I. And there we go, 0, 1, 2, 3, 4. So you might think that, hey, this is exactly the same as this over here. It's not. Again, this for loop was in fact run using code that looks like this. This is different. This is using an iterable object, range 5, which is iterable, And when it runs its loop, it just basically calls the next, it asks this object here for the next value, and then it puts that value in I, and then we have that value available in the loop. Now in languages like Java, you have the for each, right? For X in some object collection. So if you've done Java before and you're aware of that, this is more what the for in Python does. It basically iterates an iterable. And I'm not saying a collection, just an iterable. Range is not a collection. Range is not a list. And we'll take a much closer look at all that in detail later on in this course. Of course, lots of other objects are iterable as well. So for I in range, we're not going to use range. Let's say we use a list, right? So we can do 1, 2, 3, 4. And we can say print I. And again, here we go. We've printed that. We can say for C in hello. So a string is just iterable. We can get each character one by one. There we go. For C and hello, we get the string, and so on. You can even use tuples. Tuples are iterable as well. So for X in A, B, C. So I've got a tuple that contains, and let's throw in a number just for good measure. And we can print X, and we just get the individual elements of the tuple. Now, of course, you can also have more complex objects listed in an iterable type. So for example, you might have for X in, and here I'm going to do a list containing tuples. So let's say 1, 2, 3, 4, 5, 6. Right? So this list contains tuples. And when we print X, you'll see that we actually get the tuples back. Now, of course, we can unpack the tuple. We might say I, j. So it's going to take each tuple, and it's going to take the first element of the tuple, put it in I, take the second element of the tuple, and put it in j. So now we can do things like this. And we actually, as you can see, we were extracting the individual elements of each tuple that was returned every time that the next object was requested in the for loop. So we'll take a look at that in a lot more detail as well later on. Now the break and the continue statements work just the same as with the while loop. So if we have something like for I in range 5, if I equals, let's say 3, we'll continue, and otherwise we'll print I. Okay, so basically this should skip when I equals 3, and there we go, 0, 1, 2, it skipped 3, but it still continued running the loop. Now we can take the same thing, and instead of doing continue, if we do break, then you'll notice that we stop, right? So we exited the loop at that point. So we stopped iterating at that point. Okay, now you also have the else clause. So we can do something like this. For I in range, and I'll start at 1 and end at 4, and we'll print I just to see what's going on, and then we'll do this. If I mod, let's say 7 equals 0, print multiple of 7 found. Okay, and what we'll do here is we'll break. So we're going to exit out of the loop. So once we hit the first multiple of 7, we'll break out of the loop. Okay, now in this case, are we going to hit the multiple of 7? Well, no, because we're going to have really, we're going to be iterating over the numbers 2, 3, and 4. So that's never going to happen. So let's put in a break, an else statement. And well, what's going to happen if to reach the else statement? How does that get reached? Well, it only gets reached if we never hit the break. So it means we didn't find a multiple of 7. So we can just write no multiples of 7 in the range. Okay, something like that. So if we run this, you'll see that we are printing out all the numbers here, 1, 2, 3, 4, and we exhausted the loop, right? We ran through this range 1 through 5, so 1 through 4 inclusive, and we didn't find a multiple of 7, so the else ran. Now if we make this a little larger, let's go to 8 so that we include 7 in there, then you'll see that we found a multiple of 7. Now of course there's better ways of actually finding, if we have a multiple of 7 in a range, but this is good enough as an example of the break and the else and how they work together. Also, if you use a try catch inside the for loop, it works exactly the same way as with the where clause. The finally statement will execute whether you put break or continue inside your try or catch statements. The finally will still execute if those get encountered. So let's take a look at a quick example for I in range. Let's do again range 5. And we're just going to print out some characters to indicate the beginning of the loop so we can see what's going on. And we're going to try doing this. We're going to try 10 divided by I minus 3. So when I is 3, we're going to hit a problem. We're going to have a division by 0 error. So we're going to catch that. So we're going to say except 0 division. Let's make sure I spell error correctly this time. And we'll print divided by 0. Okay? And we're going to continue the loop. We're not going to break out of it, but we're going to stop that current iteration and move on to the next one. We don't want to deal with, when we have a value of I that's going to cause a division by 0. And then we want to do something, though. We're going to put the finally in. Now, all this is kind of, not exactly practical code, but it's good to illustrate what's happening. So finally, it's just going to print always run. You're probably not going to write anything like that in your code. You're going to do something that handles, maybe closing a connection, maybe handles some open transactions, whatever it is, you can put in there. Okay, and then we're going to print I in the main body of the block, of the loop block. Okay, so if we run this, let's see what happens. So you'll notice that no error happened here. So we printed the beginning of the loop, right? This was the print, the beginning of the iteration. We didn't get a division by 0 error, and then finally ran. Same thing with when I was, and then we printed I, which was 0. Then we did the same thing again. So we start the loop again, we print always run, we print I, which was 1, etc. When we hit 0, then look what happened, right? We printed, first of all, the beginning of the loop, right here. Then we printed divided by 0 right here. Now we put a continue in here. So technically, we should have gone immediately to the beginning of the next loop. But that didn't happen. What first happened is that we printed always run. And then we went to the beginning of the next loop. There are a standard number of techniques that you can use to iterate over iterables. So the standard one, which we saw just now, is this one, for C in S, and then we print C. And so we get that. What you don't get here is the index if you're talking about a iterable that is indexable, right? That has indexes. For example, a string or a list or a tuple. All these are iterables that also have an index. You can talk about the first element and the second element and the third element. You can talk about that. When you talk about sets, well, sets, and we'll see all this later in detail, but sets are iterable, or dictionaries. They're iterable, but they don't have an index. You can't talk about the first element of the set or the first element of the dictionary. There is no concept of first and last. There is no ordering of objects inside a set or inside a dictionary. But they are still iterable. You can still, start somewhere and then just call next to get the next thing. But we'll see how it works exactly with sets and dictionaries. It's a little different because sets, well, dictionaries have keys and values, and the keys actually are iterable and the values can be iterable. And then you can also iterate over the key value pairs, but it works just a little differently. But it's still iterable using a for loop. This is a little different. This has an index, right? We can say that H is at index 0 and 1 is at index 1 and so on. So we want to be able to get the index back. So you might be tempted to write something like this. Right? So we have S equals hello, I equals 0 for C and S. So now we're going to iterate C over S. And we're going to print this I, which is going to be our index. And we know we start at 0. So our first index will be 0. We'll print the character and then we'll increment I. So when we do this, we get, 0, H, 1 was E, 2 is L, 3 is L, 4 is O. Okay, So that works. I mean, there's nothing wrong with this piece of code, but you have something that you can use that might be a little simpler, which is to just use indexing. So you might do something like this instead. Let's try again, s equals hello. And here we're going to say for I in, and here we're going to use a range. And we're going to range over what? Well, we're going to range from 0 to the length of the string s minus 1. The last index will be the len of s minus 1, right? So the range will be from 0 to len s minus 1, because as we know, the high number here in the range is not inclusive. Okay, so if we do that, we can then print I and si. So that's another way of doing it. If we run this, we get the exact same thing. That's just another way of doing that. But there's an even better way that we can use. Now again, I'm not saying this is wrong. It is not. It's perfectly fine code. It's fine. This as well. This code works. But it might be a little easier to write and understand what's going on here. For I comma c in, and we're going to use a special function in Python called enumerate. That can work, and it will actually return the index and the element. So it's going to basically do this kind of thing that we did here manually, and here it's just going to do that for us. So it's just a little cleaner. And here we can print I comma c, and enumerate returns a tuple. The tuple, the first element of the tuple is the index, the second element of the tuple is the actual value that we're getting back from the iteration. And so we can store that into two local variables, and when we do that, we get the same thing. So that's the enumerate function. Very handy, and it saves you having to write this kind of code over here, which, although perfectly fine, this is a little simpler. It's also quicker to read and easier to understand what's going on. Okay, you're enumerating s. Here, I'd have to say, okay, you're declaring, I equal to 0, and then you're just incrementing. Okay, so that's the index. Yeah, you have to read the code a little bit and spend some time understanding what it does. Whereas this is immediately obvious what you're doing because it's a standard function and we know what it does. All right, thanks for watching, and I'll see you in the next video.